Hi everyone, we're going to find the domain of each logarithmic function. The main thing you need to know is that when you have a log or ln, natural log, doesn't really matter what the base is, the quantity has to be positive and it can't be 0. So anytime whatever your x is, whatever you have in this quantity, this has to be greater than 0. Same for ln. Some quantity, let's just call it x, has to be greater than 0. And so that's how we're going to set this up. If we look at this first one, for our domain, this quantity inside here has to be greater than 0. So what I'm going to do is just set it up that way. Has to be greater than 0. Go ahead and move that 4 over and divide both sides by 4. You get 3/4 is greater than x, or x is smaller than or less than 3/4. And that's your domain. And you can write it, basically a lot of teachers like you to write it like this. Since it can't equal 3/4, and the reason it can't equal 3/4 is that would leave that 0, and it has to be greater than 0. And that's how you would write your domain. That would be interval notation. And set notation, you would just take this and you could put x as all real numbers, belongs to all real numbers, but that's the restrictions. Alright, next one, the same thing, except it's ln. This has to be greater than 0, this quantity, so we're just going to set that to be greater than 0. So 5 is greater than 2x, and x is going to be less than 5 over 2. You divide both sides by 2. So, or you can write it this way. Now, again, let's just write it as negative infinity to 5/2. And it can't equal 5/2. So, this one, this has to be greater than 0. Alright? So, I'm going to write this here, and it's going to be, that would be x. So you divide both sides by -4, you get x is greater than 0. Well, it can't be greater than 0, because if you plug a 1 in there, that's going to be negative. That's going to be -4. So in this case, we want our x to be less than 0. Because if you plug in -1, you'd have ln of -4 times -1, and that's going to be positive. And you multiply two negatives. So we want it to be less than 0. It could be 1/2, 1/8, -1/8. So what we're going to write is negative infinity to 0. The next one we have is this one. Now, if you notice on this one, if you set this to greater than +1, you're going to get x squared is greater than -1, which is going to give you, if you do absolute value, is greater than I. Because if you square root both sides, you get plus or minus square root of -1. And usually when they're asking for the domain of logs, they're asking for the real number system. So in this case, since we don't really want to deal with the complex number system, we're going to say it can equal all real numbers. So it is all real numbers. You can just say x is it belongs to all real numbers, because we're not going to even consider the complex numbers. Any number you square in here is going to be positive. And then for the last one, we have this one. This has to be positive. So let's just set that to be positive. You're going to get x squared is greater than 9. Or you could say the absolute value of x is greater than 3. And basically what we did, if you take the square root of both sides, you get plus or minus 3. Now if you recall for absolute value, remember in Algebra 2, if you have something like this, you have to split it up. You're going to get x is greater than 3, and then when you split up the other, this is a simple one, you get x is less than, and you have to switch the sign, negative 3. So basically we're going to go from negative infinity to negative 3, or, and this you can, that's your or statement, or you can say unites with 3 to infinity. Now that made it all complicated, but you could actually, instead of doing all this, just look at it. We know 3 squared will give you 9, and 9 minus 9 is 0, but you can't have 0, so it has to be bigger than 3. But also negative 3 works. Negative 4 works. If you plug in negative 4, you get 16 minus 9, which is positive. So this is your answer on this. And that's all. Thank you. Have a nice day. Bye-bye.